Hello there, Mr. Wilson here again, to talk you through some non-calculator questions. Now, this is just sort of like a random mix of questions that I'm going to go through today. It'll probably take a few parts. This is mainly for some of my students that are sort of sitting some non-calculator exams soon, and just sort of going through some non-calculator style questions that might help them out. But obviously, these questions are, useful for anybody who is sitting at any non-calculator exams. I should mention these are GCSE questions, not A-level questions. So let's jump straight into it then. What I'll do as well is I will timestamp all the different topics that are in this. So if you look in the description and you see a topic that you think, oh, I kind of want to know more about that, then you can sort of jump straight to that part in the video, or you can watch all of it. You do whatever you want to do. So let's jump straight into it. Circle the number that is closest in value to 9.8 divided by 0.0195. Now, this is kind of a classic example at a non-calculator where a lot of students would try and sort of work this out exactly when there's actually no real need, because all this question is really saying is estimate this value, the value of that, and it should be around about either 550, 500 or 5,000. So if we round each of these to one significant figure, well, 9.8 is going to be approximately equal to 10, and 0.0195 is approximately equal to 0.02. So what we are basically saying is we want an approximation of this. We need to work out 10 divided by 0.02. Now, dividing by decimals tends to be a tricky topic for a lot of students without a calculator. And I know actually recently there have been some exams where they've tested this exact topic, divided by decimals. Now, to divide by decimal, the one way I like to think of it is, well, if I just multiply this number by 100, multiply this number by 100 to get 2, so divide it by 2. Well, what I've technically done, right, is I've multiplied the denominator of this fraction by 100. That's what I've technically done by doing that. So in order to keep this fraction or this division the same, I have to multiply this number by 100. So I get 1,000 divided by 2, and that's equal to 500. So that is kind of the technique I would suggest for dividing by decimals, is think about what you need to multiply this number by to make it a whole number. And then you have to do the same to the other side, because this is technically a fraction, and whatever you do to the numerator, you do to the denominator, and vice versa. So this here, the closest value from the four options of this is going to be 500. Okay then, calculate this and give your answer as a mixed number in its simplest form. So first things first, to add any fractions, they have to have the same denominator. So let's make them both out of 40. Why would I do that? Well, 40 is the lowest common multiple of 5 and 8. So 40 is in the 5 times table and 40 is in the 8 times table. So what do I do to multiply this fraction? What do I need to multiply this fraction by to have the denominator of 40? Well, I multiply this fraction by 8, because 5 times 8 is 40. So if I multiply the denominator by 8, as I talked about in the previous question, whatever you do to the denominator, you do to the numerator. 8 times 3 is 24. And then, what do I multiply this fraction by to get a denominator of 40? Well, I multiply it by 5. So I do the same to the numerator. 5 times 5 is 25. So you get something that looks like this. And this is going to add up to 49 over 40. And then it says give your answer as a mixed number in its simplest form. So when you add these together, you get this. Well, this is the same as 1 and 9 over 40. And that is in its simplest form, because 9, the only multiples of numbers that go into 9 are 1, 3 and 9. And 3 doesn't go into 40, neither does 9. So this is going to be 1 and 9 over 40, like that. Okay then, so now we're going to move on to some vectors, specifically column vectors. Now, if you are adding column vectors up, you just literally add up the x numbers and the y numbers. So column vectors are written xy, a number on top of another number. So if we are adding column vectors, we just add the x values, we add the y values. So -3 plus 5 is equal to 2. And 2 plus 7 is equal to 9. So this is going to be the column vector 2, 9. We don't write a line in between like you would for a fraction, because this is not a fraction, it's a column vector. So it's just brackets, number on top of another number with no sort of dividing line in between. Then for this next one, if you multiply a number by a vector, so this is 2 times this, you just multiply the 2 with each number. So this is the vector 2, -6, and we are taking that from the vector 3, 4. Now the only thing we've just got to be careful here is about that this sort of negative, subtracting a negative number. 3 take away 2 is 1. 4 subtract -6 is +10. So this is going to be the column vector 110. Okay then. A is 0, 2, B is 6, 5, and their points on a straight line A, B, C, D. AB is the same length to BC, which is the same length to CD. Work out the coordinates of D. Now, this is actually not a sort of terribly difficult question if you sort of think about the question in the right way. So because we know that this is a straight line, well, we know that all these points are going to sort of follow each other. They all follow the same pattern. And we also know the fact that the distance between A and B is the same distance between B and C. Which also means, because again they're on a straight line, however far you go across from A to B is the same as how far you will go across from B to C. And it's the same for how far you'll go across from C to D. They're all the same as each other. And similarly, how far you go up from A to B, so the y in the y direction, is the same, and how far you go up from B to C in the y direction is the same, and how far you go up from C to D in the y direction is the same. So how far do we go across from A to B then? Will we go across 6? So therefore this must be 6 and that must be 6. And how far do we go up? We go from a y coordinate of 2 to a y coordinate of 5. So we go up 3, go up 3 there, go up 3 there. So really it's just sort of now adding these bits on to this coordinate B. So we start on an x coordinate of 6, we go across another 6 and across another 6 to get to D. So 6 plus 6 plus 6 is equal to 18. So D must have a coordinate of an x coordinate of 18. And the y coordinate of B is 5. And we're going to go up 3 and another 3 to get to D. So 5 plus 3 is equal to 11. So D must have a coordinate of 18, 11. Quite an interesting question, that one. Okay then, a classic question now, expanding and in some cases simplifying as well. So expanding, there are sort of two ways to do this. One way is to use what might be referred to as the FOIL method, or sometimes the line method, depends if it's double or single brackets. So basically you draw a line here. Everything on the outside has got to get multiplied by everything on the inside of the brackets. So this line represents a multiplication you are going to do. So 3 times 2x is 6x. 3 times 7 is 21. And it's a positive there, or addition there. So there's going to be an addition in the answer. So it's 6x plus 21. Same idea here. We've got 4x times 5, which is 20x. And then 4x times x is 4x squared, and then there's a subtraction there, so there's going to be a subtraction in the answer. And then for this one, for double brackets, personally I always recommend the grid method. I think the grid method is the best way of doing double brackets. So I'm just going to sort of do the working out up here, just so it's a little bit out of the way. Now to do the grid method, what you would do is you'd write one of the brackets along the top, so let's write x plus 3, and then we've got x take away 2. And in the grid, you multiply each of those terms with each other to find a value in the grid. So x times x is x squared. X times positive 3 is plus 3x. X times negative 2 is negative 2x. And negative 2 times by positive 3 is negative 6. A really common mistake when using the grid method is to say something like negative 2 and positive 3 is positive 1. Right, we're not adding when we fill in this grid, we're multiplying. So it's going to be negative 6 because a positive times a negative is going to be a negative answer. Now we just need to collect together the like terms, right? Because this term here and this term here both have an x in, right? So if we were to write this out, we would have x squared plus 3x take away 2x take away 6. But this plus 3x take away 2x, well, that's the same as saying plus 1x, yeah, or just plus x. So the answer to this is going to be x squared plus 1x, or just x, take away 6. Okay then. For the next one, we're just going to sort of use that line method. I usually use the line method with single brackets. That's kind of how I do it in my head. You can alternatively still use the grid method. So very quickly, to show you on this first one, you can still use the grid method. It's going to be a little bit of a smaller grid because it's only single brackets. The 2 is going to go here. X plus 6 is going to go across the top. 2 times x is 2x. 2 times 6 is 12, and it's a positive. So the answer of this part here is going to be 2x plus 12. And again, you would have got the same answer if you would have done the line method. It's just a different way of representing the same thing. And here, if you, whatever method you would do, you would get 9x. 9x take away, negative 9x is negative 3 times 3x. So it's going to be negative 9x. Negative 3 times negative 4 is going to be positive 12. So just be a little bit careful about these negatives. Okay, it's a negative 3 times by everything in the brackets. And obviously when you multiply a negative by a negative, you're going to get a positive answer. So just be really careful with those negatives. It can be an easy mistake to make, especially on a non-calculator. And then here we just need to collect together the like terms. So we've got a, let me use my highlighter here so we can sort of see it better. We've got a positive 2x and a negative 9x, and that is going to be negative 7x. And then we've got a plus 12 here and a plus 12 there, so it's going to be plus 24. Okay then, final two then. Again, I would use the grid method for this one here. I think it's going to just be the sort of easy way of doing this question. So if we draw ourselves out a grid, we write one of the brackets across the top, we write one of the brackets down the side. Now, it doesn't matter which way around you write the brackets, because multiplication is commutative, so it can be done in either order. So whether you write the first bracket on the top, second bracket down the side, or vice versa, you will get exactly the same answer. So here we're going to get 6x squared, because 3 times 2 is 6, x times x is x squared, so it's 6x squared. 3x times negative 3 is negative 9x. 2x times negative 1 is negative 2x. And negative 1 times negative 3 is a positive 3, because it's two negatives multiplied with each other. Now this is going to simplify to get 6x squared, take away 11x plus 13, and that is going to be our final answer on this one. So 6x squared take away 11x plus 13, like that. Okay then, so just an extra thing to point out about the grid method. One thing that students tend to struggle on, or tend to sort of make a mistake, is they do all this fantastic working out, and then it's this step here where they have to collect together these like terms, and they struggle understanding the idea of how to collect these together. Because I've seen some students before, for example, for this one would put negative 7x. They sort of do negative 9 plus 2, they get negative 7. Or vice versa, I've seen like a negative 2 plus 9 as positive 7. before, 7x. So when you collect together like terms, you just got to think to it as like putting them together, right? If you have negative 2x and you add on a negative 9x, it's going to be more negative, isn't it, right? Because you're adding a negative. There's going to be more negatives in total. So it's going to be negative 11x. Okay, so it's this kind of idea of just adding and subtracting negatives that students tend to struggle with when they're collecting those like terms. So that would, if you are expanding brackets and it's one thing that you're not massively sure about, look at that. That might be the mistake that is being made, and double check that works. So that when you collect together these terms, they do make the right thing. Okay, then for this last one, on here, it's just about the notation I just want to talk about. So when you're squaring a bracket, this is actually the same as saying x plus 11 in this case, right? When you square anything, right, squaring just means to multiply by itself. So if you square a bracket, you multiply the bracket by the same bracket, right? You get a double bracket with the same thing. And if you use the grid method on this, and I won't go into depth about it because I've spent quite a lot of time talking about the grid method, but if you were to do the grid method on this, then you would get x squared plus 22x plus 121. Okay then, so expanding, definitely something that comes up quite a lot. It can be just like this, where you do an expanding question, or it can be sort of in context of a certain situation, or like a problem solving type question, but you definitely have to be good at expanding brackets, single and double. Okay then, factorising. So factorising is the opposite of expanding, right? So you have an expression in algebra and you want to put it back into the brackets. Now, there is a big distinction here between the sort of expressions on the top of this line and the expressions on the bottom of this line. Below the line, sorry, should I say. The ones on the above this line are single bracket, and the ones below the line are double bracket. Now, there is a reason for why I know this, right? You could say, oh, it's years of doing maths questions. It is years of doing maths questions, but there is a key difference for what makes something a single bracket factorisation or what makes something a double bracket factorisation. Now, the most common answer that I sort of hear is, oh, if it has a square in it, it's double. But this one has a square in it, and it's single bracket. So that can't be the rule, right? If it has a square, then it's double brackets. That can't be the rule, right? The rule is, and this is definitely something to remember, it will always be single bracket if there is a common factor of each term. Okay, what do I mean by this? Well, look at this first expression here. Is there a number or a letter that is a factor of each of these terms? Okay, that goes, you might say, this is kind of dodgy language, but you might say goes into each of these terms. Well, there is. It's 3, right? Because 3 goes into 3x and 3 goes into 6, right? So 3 is a factor of both 3 and 6. That's why we call it factorisation, right? We're going to pull that factor out of those numbers. So here we would have 3 on the outside of the single brackets. And then you ask yourself the question, what do I multiply 3 by to get 3x? Well, it's going to be x. And then what do I multiply 3 by to get a positive 6? Well, it's a positive 2 because 3 times 2 is 6. And that's it, I factorised it. So in this case, 3 was the common factor. It's actually the highest common factor of these terms. Now, just to kind of put in that into perspective, right, 1 is always going to be a factor of every term. What I mean by there is a common factor of each term is it's a common factor bigger than 1. In this case, it was 3. Okay, we are going to come back to this single bracket in a second, but just looking at this double bracket one, the reason why it's double brackets is because there is nothing, there is no number, no letter that is a factor of each of those terms. You might say y is a factor, but y is a factor of the first term, it's a factor of the second term, but it's not a factor of the third term because it doesn't have a y in it. And you might say, oh, well, it could be 3, but 3 is only a factor of 36, but it's not a factor of 13y, because 13 is prime, and it's not definitely not a factor of y squared, because it doesn't have a coefficient. So there is no common factor of this, which is why it has to be double brackets. Okay, so that is the key distinction of how you can tell single bracket from double bracket. It's nothing to do with the fact it's squared. It's to do with the fact of there being a common factor and there not being a common factor. Okay, so back to this single bracket factorisation then. So what is the highest common factor of each of these terms? Now, how I like to do this personally is I sort of look at these and I think, well, what do each of these terms have? Well, they each have p, so p has got to be part of the highest common factor, because each of these terms has at least one p in it. This has p squared, but they at least have one p. Well, you might notice as well that each of the numbers, the coefficients of these terms, are multiples of 4, right? So they all must have 4 as a factor. So 4p is the highest common factor. It's the highest factor that goes into each term. And again, this could be single brackets. What do I multiply 4p by to get 8ap? Well, it's got to have a 2 in it, because 4 times 2 is 8. And it's got to have an a in it, because where is that a going to come from if not from this multiplication? It's got to have an a. So 4p times 2a is 8ap. Okay, next term then. How do I get 12cp? What do I need to multiply 4p by to get that? Well, it's going to be 3c. And then how am I going to get negative 4p squared? This would be negative p, because negative p times 4p is negative 4p squared. And that's kind of how I go about doing a single bracket factorisation. It's all about sort of working backwards. Okay, if this is the answer, and I know I've got to multiply by this, then what is going to let me multiply by that to get my answer? That's how I sort of think about it. Okay, then for double bracket factorisation, you need to think, is there two numbers that multiply to make 36 and that add to make negative 13? Well, let's just set up the double brackets. It's going to have a y there and a y there, because as we talked about expanding earlier, if I was to expand these brackets, y times y is y squared. So that's where I'm going to get my y squared term from. So both brackets must contain a y. Okay, I want two numbers that multiply to make 36 but add to make negative 13. Well, the fact that they multiply to make a positive but add to make a negative means that both these numbers have to be negative, right? Because when you multiply negative by a negative, you get a positive answer. But when you add a negative and a negative together, it becomes more negative. So it's going to be a negative answer. Now, because the only options I can use are numbers that multiply to make 36, there are only so many, so I might as well write them down. So numbers that multiply to make 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And as we've discussed earlier, all of these have to be negative, so they're negative pairs. And then all I need to decide is which of these pairs will add to make negative 13. Well, it's going to be negative 4 and negative 9, because all the other ones don't work. So here it's got to be y take away 4, y take away 9 as the double bracket factorisation. Okay then, factorise fully 2y squared take away 50. Now, I'm going to kind of show a technique now that I think is a really valuable technique to have, especially for a high-level mathematician, you know, someone who is looking for those top grades. This is quite a high-level skill. The idea is that could you, well, first of all, I know it must be double brackets because there is not really anything that goes into these. But in this case, there is something we can do first. Right? There is actually a single bracket factorisation you can do first, because 2 goes in is a factor of 2y squared, and 2 is a factor of 50. So I could perform a single bracket factorisation on that. So I'll get 2 brackets y squared take away 25. So what I've done by doing a single bracket factorisation is I've kind of made this smaller and kind of a little bit more manageable, a little bit easier to factorise. So now I need to just factorise this. Well, this here is a very special type of quadratic. Now, any student of mine who's watching this will know that I will never stop ranting and raving about this special type of quadratic. It is my favourite type of quadratic. It is, as I would refer to it, as dots, right? The difference of two squares, or as I like to shorten it to dots, right? So the difference of two squares is a special type of quadratic, and I'm just going to sort of extend my page here, and hopefully you'll be able to still see that. So whenever you have a square, so let's say, for example, x squared, and you take the difference, so that means a subtraction, with another square, let's just say it's 4, then this has a special factorisation, right? Because both of these are squares and you are subtracting them, it is going to be x plus 2, x minus 2. So it is the first term square rooted goes into both brackets, and then the second term square rooted, but one is a plus and one is a minus. That's the basic kind of sort of general form of the difference of two squares. So in our example, we've got y squared take away 25. The factorisation of this is y plus 5, y minus 5, right? Because it's dots, right? It's two squared numbers subtracted from each other. So here, this factorisation is going to be 2 brackets, y plus 5, y minus 5. Now I can't remember that, I can't forget that 2 on the front. That's still part of the factorisation, so I have to keep it there. But that would be factorised fully. The key term here is fully, right? If I would have left it like this, I haven't factorised it fully. I factorised it partially because I've taken the 2 out as a single bracket, but I haven't factorised fully because it is then a double bracket factorisation. So just a really interesting technique there where you actually could do a single bracket, then a double bracket factorisation straight after each other. So quite an interesting idea there. Okay, then finally, then factorise this one here. Now, whenever the coefficient, I'm just going to sort of move some of these things about so I can squeeze my answer in. Whenever the coefficient of the squared term is not 1, it can be very tricky to factorise. More tricky than if it was just y squared. In fact, it's 6w squared makes it trickier. Now, first of all, I would always suggest you look for the technique that we did last time, in the last question, where can you do a single bracket first? Can you make it easy for yourself by taking that 2 out as a factor? And in this case, no, because 11 is prime. So the only numbers that are factors of 11 are 1 and 11, and they are not factors of any other number here. So we can't do that technique of pulling a factor out of single brackets. We're just going to have to go straight into it for double brackets. Now, the reason why this is tricky, and this is especially tricky because it is a 6w squared, it would be easier if this number here was prime. And I'll explain why in a second. It's easier if that number's prime. But here there are several options, right? It could be that this double bracket factorisation is a w and a 6w, right? Because that's how you're going to get the 6w squared. And there is an alternative, right? It could be that the brackets are 2w and 3w. And it could be either of them, right? They're both completely valid because, completely valid to get a 6w squared term because they both multiply to make 6w squared. Now, we just need to kind of work out which of these forms is going to be the correct way. Could be, by coincidence, that they might both end up giving a correct solution, but we don't know that until we sort of try. Now, again, we still only want numbers that multiply to make negative 10 and add to make negative 11, but there is a slight complication which we'll talk about in a second. So the only numbers that are going to multiply to make negative 10 are 1 and negative 10, 2 and negative 5, or the opposite way round, right? You can have negative 1 and 10, negative 2 and 5, right? So you can have these numbers or the other way around. Now, here's the problem, right? Whatever number you put here, for example, is going to get multiplied by 6, and then you add it to the other number to make that negative 11. Why? Well, if I was to do, let's just say, for example, right, this is probably not the answer, but let's just say, for example, it is this plus 1 and minus 10. Right? This is not the answer, but let's say it was. If I was to expand these brackets, and you can use grid method, or you can use the FOIL method, as it's sometimes referred to. If you were to expand these brackets, you would get, and I'll do the full working out just so you can see the point that I'm trying to make here. Get your grid ready. W plus 1, 6W, take away 10. 6W times W is 6W squared, which is exactly what we wanted, because that was the whole point of putting W and 6W there, because we know it's going to be 6W squared. 6W times 1 is 6W. W times negative 10 is negative 10W. And negative 10 times positive 1 is negative 10. Now, if we combine all these the like terms together, as we did when we were expanding the brackets previously, we would get 6W squared, take away 4W, take away 10. Now, that is obviously not the answer we were looking for, because that's not what they've asked us to factorise. Now, the point I'm trying to make here is that, did you notice how when we put this 1 here, usually when you expand, it's just going to be 1 times W is 1W. But that's not true in this case. It was 1 times 6W. So this coefficient ended up getting multiplied by 6, right? So the number that you put in the opposite bracket to the 6W is going to end up getting multiplied by 6. Then it's going to get added to the other value when you combine these terms together to make the middle term, if that makes any sense. So you've just got to be a bit careful here, because like in this example here, when I put a plus 1, it's not going to be plus 1W, it's going to be plus 6W. And then when you combine it with this other term, it's going to give negative 4W. Now, how can you really factorise this? There are sort of a few ways of doing it, some of which are quite complicated and involve, sort of not algorithms as such, but sort of a system. Personally, I just sort of almost do it by a bit of trial and error, right? But almost by inspection is the kind of way I sort of would look at something like this. So here I know there are only 4 options, right, for these numbers. So I would literally just try some of them and see what happens, right? Obviously you can't put a negative 5 here or like a 10 here, because it's going to get multiplied by 6, as we just talked about earlier. You end up going to get something like 60W, and that's, even when you add on the other number, that's going to get nowhere near negative 11W. So you just got to be a little bit careful about sort of what numbers you are putting where in each case. So, like I said, it's a little bit of an inspection, but it's also a little bit of sort of using a little bit of common sense. So, if we look at the factorisation closely, I don't think it's going to be this W6W idea. The main reason is because if you end up putting, sort of 10 and 5 into these sort of slots, it's going to be too far away from this negative 11W, as we've shown here with one example where you use 1 and 10. It's not going to get anywhere close to negative 11W. So I don't think it is going to be this. So I'm focusing mainly on this idea. Well, if I put a 1 here and a negative 10 here, I'm going to get negative 20W plus 3W when I expand them, which is a negative 17W. Again, that's not going to be really that close. Well, what happens if I put negative 5 here and a plus 2 here? Well, if I was to expand these brackets, and again, you could use the FOIL method or the grid method, you would get 6W squared. And then you would get 2w times plus 2 is plus 4w. And then you would get negative 5 times 3w is negative 15w. Negative 5 times positive 2 is negative 10. And when you combine these together, you get 6w squared, take away 11w, take away 10, which is exactly what they want us to factorise in the first place. So I know that this here is the correct factorisation for that question. So, like I said, there is a sort of, not a method, but there is like what's the correct word here? Like an algorithm for doing quadratics that have a coefficient bigger than 1 in front of the squared. However, personally, I think it can be a little bit too complicated for some students. And I think even though this method of sort of trial and error as such can seem a bit wishy-washy, I think anyone can sort of just give it a go. You know, there are only so many options you can pick. So you can just sort of almost, you don't have to expand every single one using the brackets, but you can sort of exclude bad numbers to put in, and so therefore you can get closer and closer to the real answer through that. But like I said, there are several ways of doing that. That's just sort of the way that I would personally go about doing this. And like I said, when the number is quite small, like 10, there are not that many options to sort of pick from. So what I'll do there is I'm going to leave it there for this part, because I think it's going to go on quite long, and I don't want to bore your brains out too much. But hopefully this has been somewhat useful in some cases. Again, if you are wanting more practice, then there are loads and loads of websites out there. So if there's something that I've said today that you think, oh, I just want to give that a bit more practice, I think after I've explained it, I think I just want to give some questions a go. I think that is the best way of learning maths, is to actually give it a go yourself rather than just sort of only listening to me explain it. Actually get your sort of hands dirty and give it a go yourself, I think is the best way of learning it. But there are loads of websites out there. Obviously, there are homework websites as well that are fantastic, and you can search up topics for them as well. So I hope this has been useful for you, and if it has, then definitely let me know in the comments below. And if there's anything in particular that you want me to cover, then I'd be more than happy to do that in another video. So I just want to say thank you very much for watching, and I hope you have a fantastic day.